The second presentation is prepared by our colleague from Allegro, Szymon Jacoń. He is a junior machine learning engineer at Allegro Pay and focused on preparing MLOps platform in Allegro Pay and putting machine learning models into production. So, Szymon, stage is yours.
Hello, welcome guys. Today we're gonna talk about how we do ML for huge impact and scale at Allegro Pay. Probably 99% of people at this room have bought something on Allegro at least once in their life, and we have 35 millions of accounts, of which 13 millions are active buyers, which means for us that they make at least one purchase in the last year. Since the official launch of Allegro Pay in September 2021, we enable all Allegro users opportunity to onboard regarding to their purchase history, to the activity which they make, or other logging informations, etc. As Allegro Pay, we've from the very beginning, we managed to onboard over 1 million of users, which financed their purchases for 5.5 billion of Polish zloty in the last year. Okay, just to make easier, this is our tech stack. So we have Azure, Snowflake, Airflow, dbt, Python, Jupyter, MLFlow, Tableau, and C#. And now let's see what do we actually do. Okay, so at Allegro Pay we cover whole customer journey with ML models. Each of these models scores millions of observations, giving us many cost saving or generated revenue. Currently we cover typical ML models, so regression models or classification, but we currently working on deep learning models to improve our power of for predictions. Okay, so basically Allegro is use event-driven architecture, and so each of these events are really complex and costs in computing. And needs to have specific knowledge about the construction of it. So our data engineers teams prepare special ETL pipeline, which covers this step to simplify these raw events into ready-to-use entities. Okay, so as look at the diagram, we have microservices which emits events into Event Hub, which then lands into Snowflake tables in the raw format. And then some sanitization and validation steps takes place using Airflow and dbt. And finally, all of this raw tables lands into ready-to-use entities, exposed to the final users like me or like data scientists. Okay, so at Allegro Pay, we divided our machine learning platform into three main platforms: data, machine learning, and decision engine. I will provide more information about each of these during the presentation. Okay, so let's start with the information how our models trained at Allegro Pay. So we always have to start with the sample definition and feature calculation. Sample definition can be done in two ways: by automated sample calculation, so basically by the process which cover typical Allegro Pay cases, so like risk or propensity to onboard. And the only one thing which data scientists had to do is to prepare JSON with sample definition. And the second way is by manual sample calculation. So this is backdoor for more specific cases. Okay, so we have sample, and now we can do some feature calculation. All of features are split into feature groups, and each of feature group go forward on feature domain. And data scientists can choose which feature domain should be calculated to save costs. And on the end, everything lands into Snowflake feature Snowflake. So this is our offline feature store. Okay. So we have sample. We have features, and now we can start our experimentation part. Each of these building blocks are configurable and give opportunity to train benchmark model within 1 day with little to none data scientist coding. And it starts by running the experimentation pipeline on default parameters. And this step covers some basic feature selection, hyperparameters optimization, and other steps working on same level. After that, a model lands into our development environment of MLFlow, and then can be run our automated model diagnostic. Model diagnostic for us makes some metrics calculation, feature importance, explainability, and other stuff like that. After model diagnostic, we can add some custom modeling steps. and if data scientists test that steps and see that they give a huge positive impact on our experimentation pipeline, we probably can implement that step in the future to default experimentation pipeline. Okay, data scientists can use local host or virtual machines, and here it's very important for us, for example, to use spot virtual machines because they live long enough to end the experiment and help to save 90% of costs of virtual machines. So it's very nice. Okay, and after model training process, we have model definition, which is basically model recipe with all needed steps to create model. This model recipe had to land into our ML model toolbox, which is basically a wrapper for Azure pipelines, and data scientists can train, score, validate, calibrate, and do everything with the model what they want. Okay, and to do the computation, can choose workday pool or high performance pool based on needs. This step is very important because it's allow us to retrain model with our default pipeline to have 100 sure that everything goes well and nothing wrong happened with model training process either. And after that, everything lands into MLFlow production environment. Okay, so how do we deploy a model? Model can be deployed in either batch or real-time mode. But before we start with model deployment, we have to implement features. Features can be implemented in two ways, in batch and in real-time mode. Batch mode is easier one, and because it's covered by our Airflow configured, our fully configured Airflow DAG, and it's easy to implement it by SQL. And real-time feature implementation is a very specific case if we need to calculate features on the fly. And it's harder to implement because it needs to be done in C# because it's most of Allegro Pay backend. Okay. Okay, so we have implemented features. And now we want to deploy model. As a feature implementation, deployment can be do in two ways, batch and real-time. They looks maybe a bit similar, and there are some difference, but at this point, they both of them need to use our pipelines to build Docker image, which is next sent to Azure batch for batch model, or to Azure Kubernetes service for our real-time model. Okay, so my favorite part. And so it's our daily feature calculation for batch features, for batch features and batch models. It starts with checking data availability and feature creation, and then sample creation, and then a sample lands into feature domain task, in which they are connected to one big pool on which we will be calculating features. After feature calculation, one more thing. We can do feature calculation in incremental way. It's important if we have a big amount of big feature group. And it can be done by splitting feature group into smaller aggregates, which are daily updated, and after that we can calculate our incremental features. After feature calculation, we can do validation, and validation is done on per pool and per model, and can be checked into Tableau. And data scientists have on duty, and they check Tableau, and if something goes wrong, they get Slack notification with informations about data shifts or other changes, and they need to investigate them. Okay, and if everything goes well, features lands into offline feature store, so in the Snowflake. Okay, so how do we score? Batch scoring, as I said before, is the easier one. It's simple and more robust than real time, and it's the most important part of batch scoring is central Airflow DAG, which is responsible for all other tasks on the slide. And it takes data from offline feature store, send them into Azure batch service, so to batch models, get the scores, and send the scores into Snowflake. It also covers monitoring and alerting component with Tableau and Slack. Real-time scoring is that harder one. As you can see, there's more components on the slide. I will take a little brief into each of them. So maybe starts with rules engine service. Rules engine service is service which parse and evaluates rules written in JSON, and this good way to for our business teams, because they can write rules on their own without help of development team, and they can implement all the business logic what they want, basically. And then we have online feature store, online feature store, which is on top of the Cosmos DB, and it is responsible for our offline features and for real-time features. Real-time features are some kind of features which are calculated on the fly. For example, based on the credit bureaus. To get a features based on the history, credit history of user. And we have also on the diagram ML model. So it's our fast API application with model. Okay, so assume that we have user which tries to onboard. Request is sent into rules engine service, which in first send request to online feature store to get features, and after getting features, it sent features into ML model service, getting scores. Using the score, rule engine service makes a decision and return it to the onboarding process. Okay, so we also take care about monitoring. So every day after bar scoring process and some real-time scores, we can run our daily ETL process calculating, which is automated DAG to compute all of the metrics, KPIs, variable stability over time, score distribution, and other metrics like that. All of the metrics are available in Tableau and are sent in daily summary for data scientists by the email. Automated daily ETL DAG compute also SLA, or maybe do SLA monitoring and send it also by the email. Okay. We also have special case for champion challengers. So if you want to retrain, basically retrain model on the same features with newer sample, we can use our champion challenger process, which is very easy because only need 3 steps, which are actually 3 PRs. And the first one is defining parameters of sample using automated sample creation, which are sent into our Airflow with feature calculation process. Then the second step is use of model receipt to create a ready-to-deployment model in Azure pipeline. And then after that, we can define rule in rules engine service, which defines challenger configuration. Okay, so let's see on our key takeaways. For me, the most important is the first one. So collaboration between data scientists, data engineers, and machine learning engineers is crucial in designing scalable and cost-effective solutions. and probably the one that the that all the systems needs to be stable, well documented, and easily extendable. And I think they are the most important. But to be true, everything on the slide is important. Okay, it's all. So if you have any questions, please ask.
So do we have questions? So maybe I will have a question for now. You talked about monitoring data drift and basically how the features changes from a day to day after a batch calculation in the offline feature store. And what about real-time features that you said that we have online features that are taken from offline feature store, but also real-time events from like you said credit bureaus and something like this. Do you monitor those features as well?
Yes, these features can be monitored also in our not here. Okay, I can see the slide, but yes, it can be also monitored in automated ducts too, because all of the features which are which lands in online feature store on the backend, they need to be in the Snowflake tables, so we can have easy opportunity to get them.
Okay, yeah, makes sense. Thank you.
Hi, great presentation. I am curious because it's the first time I hear of a company using C# in production for machine learning. That's the first thing. And the second thing is you said that you use it for online for real-time processing, which is also another eyebrow raiser. Meaning, aren't you guys leaving performance on the table? Did you guys benchmark it against other programming languages, for example?
The use of C# is because of the our backend. All of our developers on the start of building Allegro Pay was C# developers, so it was a natural choice. But it's very fast definitely faster than Python. Or probably faster than inputting credit bureaus reports into Snowflake and calculating by SQL features. So yeah, it fits well here. But for me, it was also very strange or a different situation that we use C# on the start at the company.
Yeah, true. Another question is, what happens do you have like a system for a fallback? Let's say a model hit production and something went wrong. Like, what is your procedure in that case?
Yes. If rules engine can't receive ML model service response, it use use the historical data. But if he can't, it use the other rules, so static rules, not using ML models.
So meaning that if something goes wrong, you just take the model out of production completely?
Excuse me, can you repeat?
If something goes wrong, you take the model out of production. That's like natural, but I wanted to know, how do you guys replace it? Do you replace it with the last best model?
Okay. Yes. Before the going with to production with a new model, we score with them extra users by the month earlier. So two models works synchronously on all users for months to be sure that everything goes good with a new model. And after this step, we disable old one and only use the new one.
Okay, thank you.
Thank you. Hi. I wanted to ask you about the scale. So how many models are you serving in real time and batch serving?
Okay. For now, we have 4 real-time models for onboarding process and for and I'm not sure. And we have also 4 marketing models in the batch modeling process, and I think 3 other models for risk. So for risk or for behavioral kinda, and they are batch models too.
Okay, and how much data are you processing on a daily basis? Can you
Repeat? Can you repeat?
how much data are you processing? Are you aware or?
Okay. I'm not sure what happens. Sorry, how big is real-time process in data, but in batch, our risk model computes scores for 28 millions of users, or maybe a little more, little less. Sorry. Marketing models have 25 millions of users in daily calculation, and other models are a bit smaller, so I didn't remember everything.
Okay, thank you very much.
Okay, thank you for your presentation. You mentioned here using some custom fast API implementation as well as the C# for backend services. At the same time, you mentioned you using the AKS. Have you tried any other frameworks in order to create inference servers like PyTriton, K-server, any others? And if yes, do you have any thoughts about that?
It's on our roadmap, but on this day, Azure Kubernetes Service is the first choice because we have our clusters and it's easy to use because we have working environment.
Okay, and what about the frameworks in order to spin up the inference? You mentioned the fast API. I'm imagining there were other options to choose.
For now, fast API was the easiest and fastest way to implement the solution. But on our roadmap, we have experiments with not only Python frameworks. So it's still on our roadmap.
Okay, thank you.